So in this particular problem, you need to pause it, read to yourself, but essentially you have a car that accelerates from rest and it attains a speed of 28 meters per second in a time of 5 seconds. The mass of the car is given, and it wants us to find the average power output by the car's engine. The second statement just said it's an ideal situation, so nothing's wasted. Okay, so to find the average power by the engine, you need the work done by the engine divided by time, because once again, power is work divided by time. Well, we need to focus on the engine here because it says output by the engine, okay, or output of its engine. So same thing. So to find the work through the engine, I need the force that the engine outputs, and then times it by the displacement of the car's movement. So here, work by definition is force times displacement. What force? Force of the engine, because that's what we're interested in. Divided by the time here, time being 5 seconds is given. I don't know what F is. I don't know what delta X is, but what I do recognize is that really we're given enough information to find A, right? Here you have a change in velocity if it went from 0 to 28, and then the change in time is also given. So hopefully your kinematics kicks in. You have a change in velocity, change in time. That allows you to find A. Because I can find A, I can go ahead and break F into MA. Well, because I don't know what F is, so I need to get rid of it somehow. But what I do know is that F is equal to MA. I know mass is 2,000. A, I don't know, but the problem gives me enough information to find it. And then I can find delta X just based on these values here as well. Okay. All right, so let's go ahead and find A. To find A, I'm just going to do delta V over delta T. Delta V is VF minus VI. VF here being 28 meters per second. VI being 0 because it says starts at rest. I wrote it out just for visual purposes there. And then divided by the time, which is 5 seconds. And then you simplify that in a calculator, you get 5.6 meters per second square. So now we know M, we know A, we know T. The only thing that's holding us back is delta X. Okay, so let's go ahead and find the displacement. So here, one of the ways to find displacement is just use the displacement function. VI here is 0, so I'm just going to go ahead and cross that out. And the rest of the work is just to the right here. 1/2 is there. A, I just found is 5.6. T is 5. Don't forget to square that. And if you simplify this, you should get 70 meters. So therefore, now that you have everything, so the average power by the engine is just mass times A, which is calculated, times delta X, which we just finished doing, which is 70 meters, and then divided by the time for this event to occur, which is 5 seconds. And if you punch all this stuff in your calculator, you should get 156,800 watts. So the unit for power is watts, and that's that. Okay. Now, there's another way to do it. So this is a typical way is to break work into force times displacement. But if you understand the work kinetic engine theorem, you can also do this. Average power by the engine is the work due to the engine divided by time. However, you can break up work into delta KE because the work kinetic energy theorem tells you that the net work done is the change in kinetic energy. In this case, there's only one force, which is the force of the engine, so you can apply this particular function. So therefore here, delta KE can be broken up into KEF minus KEI, but well, the car initially starts at rest, so there is no kinetic energy to start. So really, all I have to do is do 1/2 mvf squared divided by t. Okay, so that's what this is. So I just broke up KF into 1/2 mvf squared. The t on the denominator gets carried down. And other than that, you kind of know everything already. 1/2 got carried down. The mass is given as 2,000 kilograms. The final velocity at 5 seconds is stated in the diagram is 28 meters per second. So that's why VF there is 28 meters per second. I'm going to square that and then divide by the time, which is 5 seconds. So if you do this, the numerator reduces down to 784,000 joules, and then the 5 seconds on the bottom gets carried down. If you simplify this further, you should get the same value of 156,800 watts. Okay, so as you can see, there's a couple of different ways to do this particular problem. Pick one that makes the most sense to you. All right, stay nerdy, don't be whack.